The third sensor we would like to talk about is the esf-1. This sensor has a fork design. We have built up a conveyor belt for our customers and viewers. Why does the customer choose an ESF instead of an ESP?
The customer decides which sensor he prefers. Normally you can say all customers that want to detect labels, like in our demonstrator here, they prefer a fork design. When you have application to detect splices, splices are very often on web materials that have a width of 300 millimeters, 2 meters. Then customer prefer transmitter and receiver separated, and then they decide to use ESP4. And if you have thick material and you want to detect splices, then you must use the ESP4, because thick splices you cannot detect with the esf-1. For this, you need the M18 version with 400 kilocycles to detect thick splices.
Okay. We have learned before that a label sensor has to measure faster than a double sheet control. What about the arrangement of the transmitter and receiver in this sensor?
We have integrated the 10 degrees inclination that you can see on the ESP4 directly in the fork design. So here is the inclination also of 10 degrees.
Okay. Tell me something about the pin assignment of the esf-1.
We use here an M12 5-pin connector. Power supply needs 2 pins. We have one switched output for label detection or splice detection, and we have a second output for web brake control. And the pin 5 in the middle you can use as teach-in via PLC. It's the same like I push the button here if you give from the PLC a signal to pin 5.
Okay. Do we have it also in an M8 connector?
An M8 connector is also available then with a 4-pin version.
Okay. Would you like to show how to teach in the sensor?
The teach-in is very easily, especially if you have chosen QuickTeach. I have prepared the esf-1 for QuickTeach for labels, and the teach-in is really very simple. I push the button until the green and yellow LED flashes vice versa. I release, the teach-in process is finished. That's all.
Is it also possible to use link control software and to visualize the measurement?
This is also possible. I can visualize all the measurements, and if you like, I can show it to you. I have a link control adapter with me, like here. The link control adapter has a USB connector, as I have already introduced to you. I connect it to the laptop, and I loop in the T connector.
So with the same muster as we have seen in the theoretical part.
I have to read out the settings of the sensor. I will do it here now. And after reading out the parameter, I can go to the measurement writer. I push the button here, and now, as you can see, you see the labels and the gaps of the label. It's the same characteristic you have seen in the theoretical part of the presentation.
Okay. So can a label sensor then also detect a double sheet?
No. The labels must always be glued onto the tape here, onto the backing material. If the labels would not be glued, then the fork sensor would reject any teach-in process. The red LED indicator would flash and say failed teach-in procedure.